Hey everyone, welcome back. Today we're doing day 14 on scoping. So for this question, we'll be learning how do we scope properties as well as methods to be private within the class definition. So what this means is if the property and the method is scoped privately, that also means that if you have an object of that type, for example, in this case, object of type difference, you can't access these private properties as well as methods directly. So how do we do that is simply by putting a prefix double underscore before your property on your method. And just to demonstrate that you cannot access these private properties from the objects, I'll be defining a difference object on line 7. So our difference of type difference, and we'll be using the constructor here. And in this case for A, this takes in a list of integers. So I for I in range 3. This will give you a short list of 3 numbers, 0, 1, 2, 3. And on line 8, I am going to print out our difference dot private this private property underscore elements. So as you can see, it could not get the underscore elements property, and it complains that it has no attributes like that. But as we can see on line 3, that is defined, and that's because this double underscore elements property is private to only within this class definition. It cannot be accessed by objects publicly. So to make this, if we want to access these double underscore elements by any chance, and you really want to still make it private, you can define your own function, in this case getElements, which would simply return this list of integers like this. So we are returning the private property directly like this. And because we use the list type hint, I'm going to import it from the typing library. So let's try using this getElements here instead to get this private property instead. Let's run this. And as you can see, we managed to print out the private property over here. And the reason why we're still erroring out is because on line 22 is complaining that we do not have this property. So that property will be implemented for this question later. But back to this concept, we just proven how we can return an object's private property back by defining our own assessor methods. Usually you don't really need that, but this is just for your understanding. But let's say if you wish to make this function private as well, if we put a double underscore here, similarly, we will get an attribute error complaining that it does not have this method. That's because we have just made this method private. So that's pretty much it for scoping. It's a technique by putting a double underscore in front of properties and methods so that they're only private and scoped within the class definition. So that's pretty much it. At this point, we're ready to start on this question. And for this question, we are supposed to find the absolute difference between two integers in this list of integers over here. So these elements is a list that is passed into the constructor on line 13, and all of this code is generated by HackerRank. So in our job is to implement a function called compute difference that goes through all elements inside this property over here and find out what is the largest difference between any two elements inside this list of integers. So this will be a little tricky given what we have went through thus far, but let's get into it. So the first task will be to create the constructor that takes in an array of integers, list in Python's case, as a parameter. And as we can see, that was already generated by by HackerRank, so we're going to skip this one. The next task would be to define a compute difference method. So let's define this compute difference method. And as we discussed, this compute difference method would return none over here. And that's because for this function, its responsibility is to identify the largest difference and assign it to the property maximum difference. And we will be printing out on line 17. So now, there's two ways to go about finding the maximum difference between any two integers in this list. The first way is through the brute force approach, where you do a double iteration, a double linear scan across this underscore elements list of integers. And the idea is for every single element that you pick in the outer loop, your second inner loop will be iterating from the element to the right of it and it will continue to get the difference between these two current pairs. And you will just continue to scan through this whole list until you get the maximum difference. Not very efficient, but let's try implementing this first. So let's do maximum difference. We will be using this variable to keep track of the maximum difference. And next, I'll be having two for loops. The first for loop will iterate through all elements from left to right, and the second inner for loop will iterate all elements to the right of the outer element in the for loop and move towards the right as well. So for I in range length of self dot underscore underscore elements, this is the first outer loop, and I in this case represents an index. And for j index in range starting from I index plus 1 length of to self dot underscore underscore length of elements. Now this is the inner for loop, and now we have these two for loops. We're ready to get the I and the j element. So I element in this case would just be self dot underscore underscore elements at index I, and the j element in this case would be similarly the element at j index. And the absolute difference, the absolute diff in this case would just be absolute of I element minus j element. This absolute function would remove the sign between the after the difference between I element and j element. And our job over here, every time we get an absolute difference, would be to set the maximum difference to be the max of itself together with this current absolute difference. And once that is done, by line 13, we should get the maximum difference by now. And all we have to do is just set the maximum difference property to this variable that we have here. So let's run this against some test cases. It passes them, and let's submit them. And this passed the test cases, left with test case 4, but let's wait a little bit. Yes, all of them passed. So in this case, the time complexity, if we let the length of underscore underscore elements property be n is the length of underscore underscore elements list of integers, then in this case the time complexity be O(n) squared. That's because we are doing a double nested for loop over here, and we are doing like an iteration for every single element as we move from left to right. So because of that, like the amount of computations that you have would scale quadratically in this case. And to be specific, the number of comparisons that we have would be O(n) squared divided by 2. That's because as you move your I index towards the right side, the inner j index do not have to iterate through, will only have to iterate through a smaller slice of the list, because j index starts from one index to the right of I index. So you'll form something like a triangular comparison pattern. But regardless, after removing all coefficients for worst case time complexity analysis, we get O(n) squared. For the space complexity, notice that we are using a constant number of variables. We are not storing any copies of these self-dot elements, so space complexity would scale constantly with the size of n. But regardless, as you can see, the time complexity is really inefficient, it's quadratic. There's a better way about this. So the second method of doing this would be to use the sort approach. So if you sort the elements in ascending order, then the difference between any two elements in this list is just the two corner elements, the difference between the two corner elements in this sorted elements array. So let's start implementing this solution. So if we get a sorted elements list of integers, we'll be making a copy of self-dot elements and just sort it. So sorted self-dot underscore underscore elements, and just like that, we managed to sort our list of integers ascendingly. So because we're using the list type, I'm just going to import the list type here as well. And over here, the max diff would just be the absolute of sorted elements, 0 minus sorted elements, minus 1. Minus 1 in this case would get the final element on the right side of this sorted elements list. And just like that, we obtain our maximum difference. All we have to do is to set this property of maximum difference to be equal to this maximum difference over here. Let's run this code. pass all the test cases, and we got it. So in this case, the time complexity, similarly if n is the length of underscore underscore elements, list of integers, then because the Python standard sorted function over here uses a sorting algorithm called team sort. In this case, this team sort is a combination between merge sort as well as insertion sort, but that is out of the scope of this video. So the only thing that we have to know is that this sorted algorithm's time complexity is O n log n, which is more efficient than n squared, which we have for the first approach just now. So still way more efficient. So for the space complexity, in this case, because we made a copy of self.elements, we made a copy because we didn't want to mutate this property. You can if you want to, but it would not be nice to make too much mutations that's out of scope of what we are supposed to implement. But in this case, because we make a copy of the sort of the elements, then this will be O(n). If the number of n's that you have increased, then understandably sorted elements on line 12 would scale linearly as well in terms of memory used. So that's pretty much it for this question. So hopefully you learned something from this. The double underscore prefix will be helpful for making any property or any method private, and that's pretty much it for this question. I hope you learned something from this, and if you do, please give us a like and subscribe, and we will see you in the next video.